Okay, today we're going to do a brief introduction of what Pascal's triangle here is. Okay, so Pascal's triangle is basically a number pattern that we can use to evaluate binomials, like for this one here, for instance, this one here. If we say x plus y raised to the nth power, let's say n is greater than 3. Okay, where n is greater than 3. These are the types of problems we'd actually use Pascal's triangle for. Let's say where n is greater than 3. Okay, now we can actually use it for n is 2, n is 3, n is 4, n is 1. It'd be better, it's more commonly used when n is greater than 3. So for your expressions like, let's say x minus, let's say for your expressions x minus 3 raised to the 4th power, to expand these here expressions. Because it takes a lot of work to sit here and multiply all these out like this. It takes a lot of work to FOIL these and then to FOIL that product times these here times the FOIL of these. It takes a lot. So Pascal's triangle is actually a pattern that we can use that will help us to more quickly get to the answer. Okay, so let's go ahead and see what we can. Let's go ahead and see how Pascal's triangle actually looks. Let's say we start off with this number 1. Well, let me use a different color here. We start off with this number 1. Okay, we start off with the number 1. Now, up under 1, we have 2 more 1s. And I'm actually going to go ahead and write out his triangle, and then I'll explain to you guys the pattern that we see here. That pattern, with you guys' help, we'll figure out the pattern of Pascal's triangle. Okay? And we're not going to do anything heavy on his triangle. We're just going to do very light here. Not too many rows, and like I said, I'll explain to you guys what rows are and everything. Okay, and let's do one more. Okay, now if you guys have been looking and understand how to recognize patterns, you guys may already see that the patterns here are the following. Well, we have a 1, then we have 1, 1, and then we have a 2 directly up under here. And then out here, let's see, we have a 1 and a 3, and then a 3 and a 3. Then up under this 3, 3, we have a 6. Okay, and up under this 6, I'm sorry, not up under 6, but up under this 2 and 1, we have a 3. Up under this 2 and 1, we have a 3. Up under this 1 and 3, we have a 4. What pattern do you see here? Well, I'm going to tell you what I see, and you let me know if you agree with me. Well, I see me adding these two numbers here, 1 plus 3, and it giving me this number here. It giving me that number there. The sum of these giving me that number. 2 plus 1, and it giving me the number directly up under it. Okay? 1 plus 1, and it giving me that direct number 2. Okay, this 3 plus 3, and it giving me 6. This 1 plus 2, and it giving me 3. Okay, you see how this here this here triangle actually works. It's saying basically, if we take the two numbers before it and add them, we'll get the number below it. And that's how we get the next number. Now, these are called rows. This here is called row 0. This here is called row 1. This here is called row 2. This is called row 3. And this is known as row. Let me rewrite that. 1 minute here. And this here is known as row 4. Row 4. Okay? Now, with these rows, like I said, this is just a light introduction to Pascal's triangle here, just to show you exactly what we'll, just an introduction to see how it looks, to get comfortable with Pascal's triangle before we start to expand binomials with it. Now, let me go ahead and just show you something real quick. If we have x minus 3 to the 4th, this example here, what we actually can say, these rows come in handy because depending on what this power, depending on what n is equal to, like in this case n is 4, we take that row and these are actually going to be the coefficients of my expanded answer. So these will be the coefficients, okay? Let's say that again. These will be the coefficients of my expanded binomial. All right, so let's go ahead and write that. Okay, these will be the coefficients of expanded let's say my expanded product. Okay, this is exactly what these would be. So let's say we had x minus 3. Let's use a different number besides 3. Let's say we had x minus 4 raised to the 6th power. Well, we don't have a 6th row currently, but we will have as infinitely many rows as we need to. Let's say we have to the 3rd power. Well, since this n is equal to 3, we go to the 3rd row. And this row here, 1, 3, 3, 1, will actually be the coefficients of this expanded binomial. Okay? And in the next video, we'll see problems like that as far as how to expand, binomials expansion and what is binomials expansion and how it came about. That's what we'll discuss in the next